there.
Hello.
We are in the
Last
last
video
one.
of the unit.
There we go.
Yeah,
Sorry.
there we are. Page 24. We are going to talk about if acid will react with a metal or not. And
Yeah.
the reason why we got to do this video is because this reference table doesn't fit in many places in the curriculum. And
No,
this
this
is one
place-
of the things that it can be used to do.
Yeah.
But
One
in
other thing
general-
later in the year, and then this.
But in general, acids react with metals.
As a matter of fact, we're going to learn they react with almost all the metals.
Yes. Except for three, really.
And well, let's do it.
We'll see. So if you can figure out the table J, you'll see which three they don't react with by
Right.
looking at there. But here, if you take HCl and add some magnesium metal to it, it'll make the magnesium chloride, which is a salt of sorts.
And hydrogen gas.
So acids bubble when they touch metals.
Right, because they're releasing that hydrogen from the acid.
Right, so you know it's a chemical reaction because you got bubbles. It probably heats up a little bit when it does this.
Yeah, and we'll find that this is not one of those equilibrium reactions from the Fogel.
Nope, it's a
Because-
straightforward,
Yeah,
like,
because the gas leaves, so you
Right.
can't make it go backwards because you're not going to harvest hydrogen gas and force it back down in.
right. So reference table J helps us identify which metals react with acids to produce H2 gas, and this is how we do it.
So basically, if the metal that we're talking about is higher on table J than H2 itself, so circle H2. If I'm higher than that, I will react and form hydrogen gas. So that's just about all these other metals. So we can talk about the three metals now below it. Copper, silver, and gold. They don't react with acids, which makes them very, very stable. Okay, and that's why they are so what we call precious. When gold and silver are precious, they don't react.
No.
They stay around for a real long time.
No.
They don't degrade. And then copper, maybe not so precious, but we use it for a lot of very important things.
Actually, let me put a little of my own flair here. Copper, when you buy it from the Home Depot or down in your trade shops, you see a piece of copper, it's nice and shiny brown. Well, if you put that piece of copper outside on the roof and let it sit in the rain and snow and sleep for about a year, it's going to be like this green kind of funky tarnished.
Right. It
It's
does
react-
oxidize.
It oxidizes. Silver, Ag. You don't get to work with this in the machine shop too often because it's valuable, it's precious, it's
Yep.
the best conductor of heat in the world, aside from gold.
Okay.
A great conductor of electricity in the world, aside from gold.
And it's just not cost effective.
Not cost effective. And silver, if you got silver plated silverware or tea sets or something in the house, maybe at grandma's house or whatever, you got to polish it once or twice a year because if it sits there in the air, it slowly tarnishes and turns black. But slower than copper.
Right.
It's less reactive
And
than copper,
slower than every other metal on this list.
except for gold.
Right.
So
Gold is really
gold is actually a really cool thing. So stable, so inert that you can go out in the ocean and find a shipwreck that used to have gold bullion in it.
and it's still got pretty
It's still
shiny.
shiny and gold like it was the day it was minted because it does not react with anything. It's the least active metal.
Right,
for
and the
that-
salt water that's in the ocean will corrode most
pretty
things.
much
really,
anything.
Yeah, corrode it right
That's
down
why
to
the
nothing.
rest of the shipwreck's gone.
Yeah, I mean the wood, toast.
The cannons are all crusted and stuck and cemented together
Yep.
because they rusted together literally from all the salt. But the silver coins are stuck together in big bales and chunks because they react slowly and stick together. But the gold coins,
Nothing
pling,
to
pling,
'em.
pling, pling, just fall right. It's like the day they were made.
Yep. Cool.
They're still hard to find though.
Well, let's go look at them.
Okay.
All right. So hey, that's really it. Later on, we're going to find in kinetics and equilibrium that we can predict. First, we will redefine what spontaneity means, and spontaneous means as far as chemistry goes. And we'll be able to predict it using this chart.
Using those elements, we can say, well, this one's more reactive than the other, then it must be spontaneous. Both of these are poorly reactive. It's not spontaneous.
Right.
Compared to a third or
And
something.
that's really reactivity series. That's it. So just know how to use table J to predict if a metal is going to react with the acid to produce hydrogen.
The only other videos you got to watch this unit are for your pre-labs.
Yes, and we want to make sure those are done at home
Yeah, you're taking too much time.
in class.
Yeah, and we got to test out in 6 days.
So yeah, guys,
Petal to the metal.
we're doing a lot of choice now between all the Regents classes. You guys have got to make proper choices. Watch your videos at home.